So in this video today we're going to be going over linear approximation. And what is linear approximation, a lot of people ask. And what linear approximation is the effects of small changes. So a few examples of small changes is 27, the cubed root of 27, write that out, is 3. And how much larger is the cube root of 27.3 compared to the cube root of 27, which is 3. Another example of that is the price of a movie ticket is $9. How much will revenue be affected if the price increases to $9.50? So a couple equations that we're going to be using today is delta F is approximately, and that's approximately equal to f prime of a times delta x. And then we'll be finding the error, which is the absolute value of delta f minus f prime of a times delta x, which is this. So this delta f and this error equation right here is what our calculator gives us. So we're just going to type in our example in our calculator, and then that will give us a certain number, and then we're going to minus it by what we calculated. So we're just going to erase the examples up here. A few examples in the real world and mathematical wise. So our first example is find the linear approximation of 16.5 minus 16, both to the 1/4. So at first glance you can see that this is pretty much the same as f of 16.5 minus f of 16. So you can say our f of x is equal to x to the 1/4. So if we plugged f of 16.5 into this, we're just going to get 16.5 to the 1/4, and we plugged f of 16 into this, we're just going to get 16 to the 1/4. So now what we're going to do is use this delta f equation. This is delta f is approximately f prime of a times delta x. And so f prime of x is equal to, well, if we just use the power rule, x to the 1/4 to the negative 3/4, which is equivalently equal to 1/4 times x to the 3/4. So now that we got our f prime of x, which is equal to 1/4 times x to the 3/4. Our a is going to be 16, because we want our a to just be an exact number, not like 16.5 or some weird decimal number. And our delta x is going to be the change between the difference between 16 and 16.5, which is 0.5. So if we calculate f prime of 16, it's going to be 1/4 times 16 to the 3/4, and that's just going to give us 1/4 times 8 is equal to 1/32. So that's our f prime of a, and our delta x is 0.5, so delta f is approximately 1/32, and then we could think of this 1.5 equal to 1/2 times 1/2 is equal to 1/64, which if you type that in your calculator you get 0.015625 if you type that in your calculator. let's just make sure we get that. It's going to be 1 over 64 to 0.15625. And now we're just going to type this into our calculator and see what we get. So it's going to be 16.5. Actually, we don't actually have to type that. You can either type it in your calculator, as I said here, or what you can do is you can use f of a plus delta x minus f of a. But that's pretty much, which is pretty much just f of 16 plus f of 16 plus 0.5 minus f of 16, which is f of 16.5 minus f of 16. And you could just type this into your calculator. So what I get in my calculator is so for this delta f, so what we're going to say now is just going to erase all this, all that. So now what we're going to say is delta f, which is what I typed into my calculator, is equal to 0.15445, and f prime of a times delta x is equal to, I'll calculate it right there, 0.015625. So this is what we solved on our own. This is what we typed in the calculator. So now all you have to do is just use this equation now. So it's the absolute value of delta f, 0.1, no, that's not 0.1, that's 0.01. 0.015445 minus 0.15625. The absolute value of all that. So then if you type that all in your calculator, you're going to get 0.00018. And that's our error.